Okay, hello again. This is lesson 4. We're going to talk about vector analysis in 3 dimension. So in 2 dimension, just to recap, we're doing some of the forces in the x, some of the forces in the y, equal 0, equal resultant, it depends. Literally just physics 1. Nothing really fancy, nothing is fancy, it's just all about how you could do p cosine, p2 sine, and so on and so forth. In 3 dimension is helpful if you know calculus 3. But if not, that's not a problem at all. So, in 3 dimension, we're going to be introducing something called unit vector. Lambda. Let me just see the color of this. I think it should be good. So the unit vector is defined as lambda hat, and this is one of the things that you need to worry, or you need to care, let me say, when it comes to a homework assignment or a test notation wise. Notation. Excuse me. Any force as a vector can be written as the magnitude of this vector times the unit vector or lambda of the line of action, A, B, A, B, A, B, for example. And when I say A, B, it means, as we're doing 3 dimension, it could be actually also valid for 2 dimension. So if this is your A, this is your B, so this is what I mean by unit vector of AB. And again, if you know what is lambda AB from calculus 3, that's good, which equal to AB as a direction divided by AB as a magnitude. So AB, what is AB? AB is simply B minus A. And AB is the norm or the magnitude, x component squared, y squared, z squared. And I mean by x component of AB, for example, you have 2, 3, 4, then your magnitude is 2 squared, 3 squared, 4 squared, whatever that number, root 29. And the rest should be the same. Some of the forces in the x, some of the forces in the y, some of the forces in the z, all of them should be the same. So maybe putting all this crap, it might not make that sense to you. So let me try to give an example and see if we could make it more sense or digest it better. Here is an example. A, B, C, D. A, B, C, and D. And the question is asking find the tension in BD. I don't know what you want to imagine this. You could imagine it as awning. I don't know. Maybe you could imagine it as you're holding something in 3 dimensions and you're trying to maintain your body from movement and find this tension BD if you weigh 100 pounds, for example. So what I'm gonna do, obviously you could do it the cosine and sine. Other professors will do like sum of the forces in the x equals 0. You've got t BD the x equal blah blah, and they're like doing cosine, sine. I've never liked this, or some people do it like projection. I'm not a fan of this. What I'm a fan of, the calculus method or lambda method. So let's say that we want to write step number 1. This is, by the way, the solution, so I called it fun. So step number 1 would be writing the tension, right? Tension in terms of a vector. Meaning TBD is TBD times lambda BD. Right? So we're trying to eliminate all that headache, projection, and imagination, and being really creative, and just follow the procedure, lambda method I call it. Lambda BD, if you want to say step 2, find lambda BD. Lambda BD is BD over BD as a vector, which equals D minus B over BD as a magnitude. D is 8. This is your baseline. This is your reference. D is 8 in the K. And if you don't know that this associated with K hat, again, this is a unit vector. That's why I put a hat. Don't do K vector. That's wrong, because it's not only a vector, it's a vector and a unit vector. What is unit vector? If you don't know what is unit vector, unit. The norm, the magnitude, the length is 1. And this is J hat, and this is I hat. So 8 in the K hat minus B is 12 in the X, 20 in the Y, over the magnitude of this, so root of 12 squared, 20 squared, 8 squared. 12 squared is 144, 20 squared is 400, 8 squared is 64. So adding those all up, I think it's going to be what? 144, 64, that's 608, something like that. Let's see what is the answer. I put it in terms of fraction. So let's erase step number 1 and say that the vector BD the vector BD, so step number 3 if you want to call it, TBD is TBD times let's take this thing out, 24 point, according to my solution, 24.7, 3 sig fig is enough. Your top is going to be negative 12i, negative 20j plus 8k. And now, literally what you're going to do is just sum the forces in the x, and sum the forces in the y, and sum the forces in the z. But technically, you don't really have to do more than one summation. The reason behind this, it's a very simple problem. Start with very simple. Is this the weight is the only exerted load, and it's acting on the z direction. So I only need to do sum of the forces in the z direction being up is positive. So negative 100 plus tension in the z direction. So this is what you're looking for. Obviously including this. Plus TBD times 8 over 24.7 equals 0. Don't put J or K or anything because you are already denoting that you're summing the forces in the Z direction. Ouch, sorry. So solving this, one equation, one unknown, is sometimes you see me do this, sometimes you see me just write TBD, and that is going to be equal 308 pound. Now let's see what we've done. We've said if we're doing statics, then the system has to be in steady state or equilibrium. Hence, we will sum the forces in the z direction, since the only force W is the only force exerted on this structural, or is acting on this. So this is what you're looking for, find the tension in BD. If for some reason you're having compression forces here, then you are going to solve, or you're going to analyze or sum the forces in the x component and the y component. So you're going to have tension BD in the y should equal the compression force in, for example, BC. The compression is this. Always what I do, like C and put like this thing. So it's kind of like denoting this is not a letter C, this is compression force. So that is pretty much it for three-dimension analysis. I'm not going to do more than 1 or 2 examples on 3-dimension. I typically do not give 3-dimension problem for forces, sometimes in moment, but 3-dimension is pretty simple, except it's kind of tedious and sort of time consuming. The idea is lambda analysis, the lambda. If you know how to do this, if you know how to do lambda, then it should be piece of cake. If you cannot, then you better work on this and try to find out the coordinate. It's literally just, if you want to write this coordinate as 0, 0, 8, don't do point, because we're not doing point anymore, we're doing vector. Vector is that sharp, parenthesis, kind of like less than or greater than. So this is not good, because you're literally going from O to D as a vector. If you just say D as a vector, meaning that you already established a point, which is in this case, let's call it O. I think that's pretty much it for 3-dimension analysis. I will be covering more 3-dimension analysis maybe just with you on Monday, and we'll give you this week to recap chapter 2 if you have any questions. And next week or this week we'll be starting moment. So, and then we will have this first test hopefully by this month and max. Hopefully before having chapter 1, 2, 3, and maybe 4. Which is, you know, pretty much vector analysis, 2-dimension, 3-dimension, and moment. That's pretty much the first test. I'll sign out for now, and we'll see you in next video. See you guys.